Lacey Eccles. I am the K-12 Science Lead for JCPS, and I am pleased to be here to talk about using PhET simulations during NTI to help engage our kiddos in the practice of scientific modeling. So let's get started. So our agenda today for this kind of itty-bitty 30-minute power session is to talk about what is PhET, how we navigate the website, PhET in our standards, and then the last two I think you'll find incredibly interesting and useful is PhET in Google Classroom. We're all living in that world right now. And then PhET in our device compatibility, because we know our kiddos have all different kinds of devices at home. And so what has PhET done to make their product compatible with all kinds of devices? So let's talk about what PhET is. PhET, for those of you that have never used it before, is a collection of well over 100 interactive simulations for students to provide them with kind of an open, exploratory environment where they can engage with the science content like a scientist. And there's actually math as well. But we're not talking about math right now. We're talking about science. So let's talk about how we navigate the website. There's a lot on that website. And so, and a lot of great kind of different resources on the website. So I kind of want to walk you through some of the highlights of that website. So this is the PhET kind of landing page, their home page. And if you click right in the center, you see my Albert Einstein? If you click play with a sim, that will take you into their site. And on their homepage are any of their new sims that they've created. And that changes very often. So like today, they're highlighting several math sims that are new additions, like integers, vectors, vector addition, blah, blah, blah. So if you want to talk to your math teachers and make sure that they know about PhET, there's lots of great math simulations for kiddos to engage in on PhET. So if we scroll up to the top, you'll see a little person, and you don't have to have an account. But if you have an account, you're able to save your sims. Now, your students don't have to have the account. I'm saying as a teacher, it's free. You can save some of your sims, upload some of your lessons for other teachers. So if you'd like to create your own account, that's where you would create it. And then right over here where we see simulations, you'll see a list of all the different ways that you can search for specific simulations. New sims, HTML5, by subject matter. We could even search, for example, by math, if we were a math teacher, or by grade level. So we have elementary, middle, high, and university. And what you'll notice too is you might find the same sim in each category or in a couple of them, because the sim themselves kind of span over multiple grade levels. It's what you do with the sim that makes it elementary specific or middle specific or high school specific. All right, you can also search, check this one out, by device. Are your students using iPads and tablets? Are they using Chromebooks? These are the sims that would be compatible with those types of devices. If we go over to teaching, the first one I want to highlight is tips for using PhET. This is a great place if you want to look at some other videos that go beyond what we'll be talking about today, like interactive lecture demonstrations using PhET with clickers, facilitating PhET activities, designing PhET activities. So there's lots of other videos that PhET have created that take this one step further than what we're talking about today. So that's a great place to go for resources. You can also go to browse activities. And I really like this. So if I am, per se, a middle school teacher, and I am right now in my chemical interactions unit, I might click chemistry in middle school. Now notice I can choose all kinds of languages, but we're just going to stick with all languages. And I can click browse. And this will take me to a list of all different teacher-made resources for middle school chemistry. So maybe I want to build the atom game. And if I click on it, right here is my ability to download that resource. And so there are a ton of different resources for a ton of different categories and topics. And so that's a great place to find some things that you can actually are already made to make this a little bit easier for you. Now, if we go back to simulations, and let's stick with chemistry. And let's stick with, I'm a middle school, 6th grade teacher, and I want a simulation about the phases of matter. So I'm going to look at all of these fantastic resources for chemistry, all different kinds of grade levels, but I see, oh, here's one about states of matter. So if I click on that simulation, every simulation drops you into this kind of landing page where you'll notice, look at that right there. That's a Google Classroom, and we'll talk about that in a little bit. But you can see the simulation, and the first little bloopity is about, and it tells you what your topics are, a description of it, and sample learning goals. And those sample learning goals are a great place to start when you're thinking about what are your learning goals for your upcoming, instructional unit in NTI. But then the next tabby is for teachers, and this is great. So every PhET simulation has a teacher tips PDF. Now, not every PhET simulation has a video primer, but if I were to click on a teacher tips PDF, it takes me to a PDF walkthrough of exactly how to use that PhET simulation. It talks to me about model simplifications. It also, if you aren't really strong in phase change diagrams, it talks to you a little bit more about the phase change diagrams that are in this simulation, suggestions for use, and sample challenge prompts. Now, this sheet is meant for the teacher, not meant for the student. So this is background knowledge for the teacher. But you also, under for teachers, have a very similar thing to the PDF. But if you're more of a kind of visual auditory learner, there is a walkthrough video primer for the actual simulation. Now, again, that is for you as the teacher. You wouldn't want this to be with the students because you're kind of giving away the secret sauce if you show them the video primer. You want to give them time for some open exploration to discover what all the pieces and parts do before you give them any type of specific instructions. Because as soon as they open that, that's the first thing kiddos are going to want to do is play with all the buttons and do all the things. And so if you make some time in your instruction for students to actually do that, a set amount of time, that gets that out of the way. And then underneath it, you will see teacher submitted activities that go along with that PhET simulation. You have the level and then the type, like homework, lab, demo. This is a homework or a lab. This is a lab. So all different activities that have already been created by teachers for you to open up, look at, modify, use as is, so you don't have to recreate the wheel. Now, if as a teacher, I want to download that simulation so we can play around with it, you're going to click download. And then we're going to open up the simulation. And look how pretty that is. So this simulation technically has 3 different simulations within it. And really, this simulation can take you from elementary school all the way to high school. I could use this exact same simulation. So if we want to look at the states of matter, and we have all of these different buttons, maybe I want students to start with water, and this is water in a solid state. And maybe my question is, what happens to the molecules of water when we add heat into the system? So we're adding heat, we're adding heat, we're adding heat. Looks like they're starting to move a little faster. Oh, look, some are starting to kind of fly away from the collection. And what if I wanted students to be describing what's happening in the model? I can have a student push pause, and I can come over here to these 3 dots, and every simulation has the ability for me to take a screenshot. So think about that. I could screenshot my model, insert it into a Google Doc, and then as a teacher, I can see exactly what they're seeing when they're writing their description. So maybe in my description, I say I inputted heat into the system, and this was what happened to my system. I could also have students do some type of cause and effect, or I could get in a cross-cutting concept in this. But the being able to screenshot and pause my model kind of mid-screen, like a freeze frame, is an incredibly exciting addition to PhET simulations when we're thinking about NTI. I can go back to home, and maybe I want to think more about the phase change. So now I've added some other pieces. I've added the ability to add pressure to my system. I've added the ability to add in more particles to my system. Now, over here, there's a lot going on. And maybe if I'm a middle school teacher, we don't really care about that. And we don't really care about that. But if I was a high school teacher, we absolutely care about these two pieces. So that's a way to take the same simulation and up the rigor and up the grade level that it's appropriate for. And so one simple states of matter simulation can take us through elementary school all the way through high school. So I might be doing a 5th grade PS1 standard just about matters made of particles. Then I might be doing a middle school, PS1-4 about phase changes, or I might be doing a high school PS1-3 about the interaction between atoms and their bonding. So you can see how one simulation can take you through several grade levels. And so that's essentially how to navigate the PhET website. So if we go back to our presentation, let's talk about PhET in our next generation science standards. That is a fantastic tool to use when we're thinking about our standards. Like you just heard me talk about, that one simulation that we looked at was aligned to a 5th grade performance expectation, a middle school performance expectation, and a high school performance expectation. If you're a middle school teacher who's watching this video, right here is a live link. Some kind soul out there in the World Wide Web made a crosswalk of PhET simulations and middle school performance expectations. That kind soul apparently was not an elementary or a high school fan because they only made it for middle school. But it's live linked right here, middle school teachers, as a resource. But what I really want to focus on is how great PhET simulations are for the science and engineering practice of developing and using models. And so with our standards, there are science and engineering practices, cross-cutting concepts, and disciplinary core ideas. Remember, the disciplinary core ideas are kind of the meat in the middle, what we traditionally think of about science. But the science and engineering practices are the doing of science. And so when we think about NTI and how can we get kiddos engaged in those SEPs, the actual doing, right, the performance of science, well, PhET simulations is a great tool to virtually still engage students in some science and engineering practices. And so developing and using models is like the superpower of all practices. It's my favorite personally. And I genuinely think it's some of the kiddos' favorites. So when you think of models, I'm not thinking about a cell model that you could eat. Stephen Pruitt, one of the developers of the next generation science standards, always jokes that if you can eat it, it's not an NGSS model. And so when we're thinking about modeling in this case, we're thinking that simulations are models. Simulations are ways, if we're thinking about the one that we were just looking at, are a way to model things that we can't see. You're looking at your computer screen right now, but you can't see all of the particles that make up your computer screen, and you don't want to heat your computer screen up to see what happens to those particles as you add heat. And so that's where simulations come in. They are tools that we use to replicate systems in the real world. And systems models, just FYI, is a cross-cutting concept in our standards. So we're also hitting that as well. So the great thing about the standards are that developing and using models starts in kindergarten and goes all the way through 12th grade. We're just adding on to it. So if we think about our states of matter example, and that's really appropriate for some 5th graders. And so right here, identify limitations of models. That's one of the things that kiddos need to know how to do when they leave elementary school. And I might, when kiddos are using the states of matter simulation, I might ask them in our Google Hangout or in whatever platform you're using to have class discussions about, so what are the limitations of the models? That's a big word, right? But that's a word that the standards say that kiddos should be able to know by the time they leave elementary school. And so this framework right here is for you, but it's also for students. The language in this developing and using models is language that students should be able to use. How was this model like the real world? And how was this model not like the real world? Or I'm down here. We are using a model to describe phenomena in the real world, right? That's something we're doing in elementary school. Well, in middle school, I don't just identify the limitations, but then I'm asking kiddos to evaluate those limitations. Or maybe I'm asking kiddos down here to revise the model. So maybe we have a model and then I add some more heat. So I'm revising my model because now I know more about it. And then I get to high school and now I'm looking at the limitations of two different models. So maybe we are looking at phase change with argon and phase change with water and comparing those two models. And so you can see how it becomes more and more complex as we progress, yet I'm still using the same PhET simulation at all of the levels. And so it's really easy to use PhET simulations and dive into developing and using models, as long as kiddos know that their PhET simulation is a model and asking them, what are we modeling? And then the other science and engineering practice that I think goes really easily with, and really any of our science and engineering practices can be used with PhET simulations. We can construct explanations. We can ask questions. We can do all of them. There's just some that are a little simpler that lend themselves a lot easier to PhET simulations. And the other one is analyzing and interpreting data. And so there are several PhET simulations, a lot of physics and chemistry ones specifically, that ask kiddos to gather data. Like if I'm in energy skate park, I'm gathering data about the kinetic and potential energy of the system. If I'm in our phases of matter one that we use today, do you remember when we had that phase change diagram? Well, that's a phase change graph. And as we add heat, there are different points on the graph that change. And so that could be at a high school level, analyzing and interpreting data within that very same simulation. So for the next generation science standards, PhET simulations are ripe with opportunities for students to engage in the standards, to engage in the practices, which is a piece of the standard, to very easily engage in cross-cutting concepts like cause and effect and systems models and looking for patterns. I could talk forever about PhET and NGSS. So when students are using their PhET simulations, as long as you make it transparent to kiddos what practice they're engaged in, you are tightly aligned to the standards. So now that we've talked about kind of how to use the website and talked about how those simulations align with our standards, let's talk about kind of PhET and the usability. Our agenda said we were going to talk about PhET in Google Classroom and PhET in device compatibility. And so really, PhET has released two really short, like 30-second videos each, and they can explain it 1,000 times better than I can explain it. So what I'm going to do is I'm going to click.
With PhET's Google Classroom integration, any HTML5 simulations can be seamlessly shared with your students. Just look for the Google Classroom logo on the right side of a simulation page, select your class, then choose how you want to share the sim with your students. Your students will receive a message with a direct link to the sim, so they can easily begin exploring, engaging, and learning.
That couldn't be any more seamless and couldn't be any simpler than clicking a button and shipping it to your kiddos. So they've done a really nice job with integrating into Google Classroom. And they've also done a really nice job with device compatibility. So let's look at that one real quick.
At the beginning of the PhET project, most of our sim development was done in Java. Although all our modern development is in HTML5, many of our popular Java sims have not yet been converted, and running these older sims can be challenging. Java sim files can be downloaded by clicking the play button on any Java sim page. However, Windows users often come across the issue of not having an appropriate application assigned to open these jar files. If you encounter a flash of black screen when opening a Java sim file, or if Windows tries to open the sim with a program other than Java, try one of these methods to get our Java sims running smoothly and consistently on your PC. The simplest method to run Java programs on Windows is by downloading a utility called Jarfix, which you can access via the link in this video's description. Running Jarfix immediately makes Java the default program to run jar files, so all Java sims should open with ease. Alternatively, to manually tell Windows to open the sim with Java, right-click on the jar file, go to Open With, and select More Apps, then look for another app on this PC. And finally, select java.w.exe located via this file path on a default installation. For any other issues, check out our Help Center or shoot us an email at phethelp@colorado.edu.
I mean, wow, the fact that they are going back through and transitioning everything to HTML5, I think is fantastic. They also spoke a little bit about PhET apps. There is an app for Android and there's an app for Apple. So if you have students that are using their phones as their device, they can download the apps. A ton of their simulations have moved over to HTML5. I know they're working as fast as they can to kind of move everything over to that for more device usability. All right, so that is kind of a snapshot about PhET simulations.